This is the bounce cross method for graphing polynomial functions. Let's say I want to sketch the function f of x equals x plus 1 whole squared times x minus 3. The first step of the bounce cross method is to factor the polynomial, but since this function is already factored, we can move on to the next step. The second step is to plot all of our x-intercepts. This is when x equals -1 and x equals 3. Then we calculate the end behavior. We add up the total exponents, and in this case, this is 3. So we look at our end behavior chart, and we see that this is the case where we have an odd exponent and a positive sign. So now we can draw our end behavior on our graph. Then we take the individual exponents of every factor. X plus 1 has an exponent of 2, and x minus 3 has an exponent of 1. And according to the bounce cross method, if the exponent is even, the graph will show a bounce. And if the exponent is odd, the graph will show a cross. This will make more sense once I actually draw on the graph. So we come over here, we see that the x-intercept of -1 has an even exponent of 2, so it's going to be a bounce. And a bounce means that it comes and touches the x-intercept but doesn't cross the line. And similarly, a cross would just mean that it crosses the x-axis. How I know to draw the bounce and the crosses which way, pointing up or down, is because I'm just following our end behavior. And so finally, when I go and connect the graph, it will look something like this. Well, you might be asking, how do I know that the function doesn't cross the x-axis at any point other than -1 or 3? This is because when we first factored our function, we are already finding all of our x-intercepts, so we know for a fact that there can't be any other bounces or crosses. And of course, this is just a rough sketch, and if you want a much more accurate graph, you could potentially make a table like where you have the x and the y, and you plug in values, and you graph it like that. Or if you knew calculus, you could calculate inflection points. But this is just a rough sketch with respect to x-intercepts and the end behavior. And if we compare our sketch with what we get on Desmos, we see that it's a pretty accurate sketch.